Hello, good evening. Can everyone hear me? I suppose so, because I can hear a good echo, so that's a good sign. So thank you for coming. Thanks for sharing your evening with us. I was a little bit scared. We'll need to ask our own employees to fill in the seats, but clearly we didn't need to, so that's a good thing. What we are actually aiming for with this event is to bind the community of backenders, of engineers in general. You know, like lawyers, they kind of, even if they don't work together, they kind of recognize one another in the supermarket. I've seen him working on that case or another case. So it's something similar with engineers, that you can recognize someone from writing a good code and would like to know that. So it's an opportunity for us to network, for you to network, and also for us to share some glimpse or show you how Vinted works. In this format, we are trying it out for the first time. We are hosting some events that are more on the softer side. Maybe you've heard of tech kinship and tech leads, where there are different type of topics introduced. With this one in particular, will be a bit more technical tonight as well. So that is more to share in the insights how Vinted actually works, and to gather some feedback also from you, what's interesting, what's not, and we will be hosting similar events in the future as well. Now, what we'll be talking today about are a few topics. Engineering at Vinted, and I didn't introduce myself, memory. So I'm Aurelija, I'm a director of engineering here at Vinted for one of the domains, which is trust and safety. So I will be the one to tell you more about how engineering at Vinted works. We'll hear from Audronė on what was her journey traveling from Java to Ruby. Some of you might know that our main backend language we use is Ruby. Common question, why? So we'll hear from Audronė how she transitioned into Ruby. Then we'll hear regarding transaction processing from Giedrius. We'll also have Oleg speaking and introducing to our matching domain, how that works. At the end, we'll host Q&A. That means that after presentations, we won't leave much room for questions. We'll ask you to post those questions on YouTube channel. We work at Vinted, you can find it on YouTube. Or just if you have a better memory than mine, you can remember the questions you want to ask and leave them for the end. We'll have time for that. And if some of you came not for the speeches, but for the drinks, we don't judge. We'll have drinks on the rooftop terrace. We'll have people which know how to make cocktails. So there's some good ending for that. All right, then we can start with engineering at Vinted. So overall, as a company, we've started approximately 14 years ago. So comparing to huge companies which have been there for hundreds of years, that's not a lot. But to us, it is quite fascinating how much we've achieved in 14 years. We, by now, have reached 80 million registered users. Last week, actually, we made our most recent launch, which was in Romania. So by now, we have 19 countries that we operate in. We also operate to not that big of a size, but we are getting into the such regions as USA and Canada, and overall our estimation is already 4.5 billion. Now, when it comes to our live events, then you can see how the transactions lively looking, where seller and buyer get connected. If you don't know necessarily what Vinted does, then you can just upload your items that you want to sell. We focus on secondhand, as that is our mission, and that's where we do allow connection or enable the people to buy from different people which have secondhand items they want to sell. Quite recently, we reached our load of 149,000 requests per second. It was actually a challenge to ourselves, because the way we have scaled ourselves was also not necessarily already built for that scale. So there were some investments we had to put into our platform so that we could handle the load. And at the same time, we had to rethink, so if we scale faster and if we scale more into the same regions like USA, etc., then how and with what elements in our code base will we be able to scale fast enough to handle the load as it comes. At the same time, even though we've been operating here for 14 years, we consider ourselves still being at the beginning of our journey. There are so many different revenue streams. There are so many different regions we haven't been in yet. And therefore, everything we're building around is still considered as the beginning of our journey. Now, mission, as I mentioned, is making secondhand the first choice worldwide. So overall, the way Vinted is built right now in terms of team compositions, etc., it's not necessarily how it's been from day one. When the teams are small, when the company is small, you need to operate in one way. So what I'm going to show in the following slides will represent more on how we adjusted for the mission and how we've created the company and engineering so that we can achieve the mission faster. So overall, engineering is built into two pillars. First is product, and second is infrastructure. For infrastructure, we have 4 separate areas that are working together. IT is where our laptops get purchased for us to be used. All the support tickets, if you have been working in support area, you know that that's the place where all those tickets get in. When you want to answer, we kindly remind you to add all your tickets and all requests here. Not for some tickets you want to add that, but still that's the team which gets all the IT-related requests regarding licenses, regarding access rights, etc. Data infrastructure is the team which takes care of data warehouse, machine learning platform, experimentation platform, everything that brings the capability or enables the foundation for how data later is used in the product teams. Engineers experience, everything that you can think of how you enable engineers to work in a continuous way that is making them productive with all the environments that we have. Site reliability, as the name suggests, and it's common in all the companies, all the databases, observability, in general, knowing that we have a good uptime, we have a reliable platform, and we can sustain and keep up the load. Now, difference between our infrastructure and product teams is that in infrastructure, we have mostly engineers. We don't have product embedded, we don't have analysts or design. It's very technical domains as their nature suggests. So this is strictly engineering heavy. Now, product teams are structured a bit differently, and they operate in 8 domains within Marketplace. We have growth domain, which would be responsible how we scale to different markets or different revenue streams. For example, a Romania launch that I mentioned would be handled by growth domain. At the same time, the most recent ad they have released was Rebelle integration. I don't know if you've read or heard, but we acquired a company which enables authentication of items. So for instance, I buy a Gucci bag, I want someone to check the authenticity in the warehouse, and that company then allows us to do the service. So integration of it into our user journey would be handled by growth. Monetization, as the name suggests, how do we enable additional revenue streams within Vinted? So for instance, your item bumps or galleries or pro users, stuff like you can expect in any app, which means it costs more, but then the services users would like to buy and then get some extra or additional, some additional talk around it later. Payments. You'd be surprised that it's not about payments, but it is about payments, literally. How do we connect to our third-party providers, which allow us processing of a payment? How do we ensure that the payments are reliable, that they get through, etc. Platform is our most technical domain within Marketplace. It has transitioned into Marketplace fairly recently. The reason we have added into Marketplace because we understand that as we grow, we also need to own our own features end-to-end, so we shouldn't be leaving to site reliability all the topics and everything that goes bad. It's literally with the intention that platform can work as kind of middle layer which supports and provides the environment for different domains to own. For example, sharding of databases. If we are the owners as a domain of a database, then we would need proper toolkits and in general suggestions, how do we make them reliable? And that's where platform would come in. Community support tooling. As every company, we also have community support. So that's where our member tickets gets processed because somebody either have an escalation, inquiry, whatever it is. So the tooling they use in our help center when members want to find the answer themselves, or they want to reach out to members interested to community support, that would be the domain that creates all those tools behind so that they can be effective at their work. And trust and safety domain, since I work here, I want to say it's the most interesting domain. It's the dark side of the business. Some stuff you see, you can't unsee. But overall, it's where our account security is where we can get all sorts of stuff trying to get uploaded into the platform. Of course, we don't allow drugs, guns, etc. So that's where all that gets handled. Now, what kind of roles do we have in the domains I just mentioned? In every product team, we would have 4 roles collaborating together on a day-to-day basis. So, like in its traditional value or in its traditional understanding, we would have a product manager in every team. What product manager is responsible for? What is our team's vision, mission? What objectives do we have? How do we prioritize our backlog? How do we engage with stakeholders? It's also have a data scientist, so it doesn't necessarily suggest that we would only have one analyst. And then engineering, that comes in with the view of how do we ensure we are choosing the right technology, what decisions we're making when we are making decisions about a particular product setup. So engineering is, of course, the part where also engineers club in. So in the composition of a team, which is on average 10 to 11 people, normally you would have 4 people as so-called engineering product design analytics. In abbreviation, we call it EPDA setup, and then engineers which help to achieve the teams, to achieve the mission. Engineering roles we typically have in the teams are Backend, front-end, QA, those would be almost in every team with only a few rare exceptions. And then depending on how wide the team goes, we would also have mobilers in the team. Our tech strategy priorities, the way we organize our OKRs, as a company, we work on an OKR framework. So we would have product suggesting and also ensuring that to adhere to the mission for which team has been established, there will be certain objectives team will need to accomplish. At the same time, engineering also has objectives that each team contributes to. And overall, I think it's 13, if I remember correctly, we have identified around 13 blocks of what we need to improve to be well-equipped engineering company with our well-running tech stack. But just like with everything, you can't run on 13 priorities. So what we've prioritized are 5 blocks, where architecture, for instance, is today we are still running quite a lot on monolith. What we want to achieve is service-oriented architecture, so we would be reworking we would be moving into that direction. So our biggest engineering projects would be associated exactly to that goal. System resilience, how do we ensure, then I mentioned sharding, but all sorts of data center enabling features. How have we prepared ourselves to be resilient as a system? And then different teams would have different amount of features that would need to be reworked for one or another goal, but that would be another one to contribute to. SMP maturity, don't ask me why I left this abbreviation, because now I'm thinking what it means. Security and privacy. Yes, security and privacy maturity is how do we as a company ensure that it's built in by design. If we are building a feature, it's not only that it's member-centric, it's not only about have we achieved the goal, but also have we removed vulnerabilities it might have we built in compliance aspect into it, GDPR and stuff everybody likes. Organizational design, we understand that for teams to be productive, they need to be autonomous. And that means not only knowing which part of the code you own, but also how that correlates to your team mission. If some of you are familiar with DDD design, then it's something that we are implementing into our company, which basically suggests that your business vision should adhere to what your code ownership states, and you shouldn't have a big discrepancy between the two. Ownership, again, if you as a team own the features, then it's responsibility of a particular team to make sure it's cleaned up, it's properly looked after, what needs to be sunset, it's sunset on time, etc. So then there are initiatives that fall into different teams of how we install the ownership into the hands of the teams. And last but not least is our coding languages. So as I mentioned at some point, our main backend language is Ruby. Lately, there have been way more questions of why Ruby. In the beginning, 14 years ago, it seemed like the wisest option. It's not like you cut and rewrite everything if you change your mind. So we are still running a lot on Ruby. Our second language, which is being adopted, is Go. So in some domains, more than in others, you would already have services being rewritten in Go language. But since we've introduced that fairly recently, it's not that widely adopted yet. But again, that's what we are striving for, especially through service-oriented architecture. So it is our ambition. And the other languages I can read, but you can also read as well. Yep, so that would be it for how engineering works at Vinted. And I want to ask Audronė to come on stage and tell about her experience traveling from Java to Ruby. While she's coming here, I can tell you that when she looked at my slides and some other slides, then she said that she will definitely make better. So I'll see about that. But stage is yours.
Okay. Hello, everyone. I'm not entirely sure that what she said is true, but I will try. So, hello, everyone. My name is Audronė, and I am senior backend engineer here at Vinted. And I have been working here for a bit more than 4 years. And my talk will be a bit less technical than the others, so please bear with me. And I want to emphasize one thing, that this is my personal path from Java to Ruby. So a lot of things differ from person to person, obviously, and I just wanted to highlight a couple of things that helped me and just share my story in general. So how did I get to programming? That's a short intro. I don't have one of those cute stories where I started to program as a teen. Programming came way later in my life when I decided to change my career after university. And I decided to ditch my humanities degree and go to programming courses. This is me with my new and shiny diploma. You can see I'm very happy. And coincidentally, these courses were held in Java, so it became my first language. In my short career, I programmed with quite a few languages already, so Java, Groovy, I even dabbled in React, and now I'm programming in Ruby. So, how did I prepare for my transition? So I don't want to be boring, but it's hands-on experience. Basically, back then, our hiring process would also have a part where you could actually touch production code and try it out in a tryout session. So I did that. So even before accepting the offer, I could try to look into Vinted's code base and to see if I like it or not. And after I agreed to come here, I did a couple of online courses just to check syntax, just to check expressions and everything, and to see if I like it or not. So I'm also a strong believer that language is just a tool, and it is way more important for you to know how you want to do things and what kind of expressions and patterns to use, and not how you do them in one specific language. So after joining, this is me of one of my first days here at Vinted. You can see me sporting my new and shiny Vinted merch. I was surprised to see a very unfamiliar stack for me. So the only things that I knew before, from my previous experiences as a programmer, were GitHub, MySQL, and Spring. And surprisingly enough, this was not the same Spring I was used to. In Ruby world, Spring is a Rails application preloader. But please don't be discouraged. There are quite a lot of familiar things too. One of them is being RubyMine. So if you are familiar with JetBrains products, you will be glad to hear that there's IDA for Ruby as well. So what it meant for me is that I could keep all of my custom and the shortcuts that I'm used to, and even use the same UI. So it helped me to move along quite a bit. And when I joined, what I did, I tried to immerse myself in as many discussions as I could. Then I would listen to what people are talking, my colleagues discussing work, things like what they read recently and everything, and I would write everything down. And then later on, I would Google this or ask my onboarding buddy, or for more modern approach, you can always try to ask ChatGPT because it's going to be easier probably. As well, one of the things that I could advise for people is to try to get a lot of different tasks, especially when you are starting out, because this way you will get you to know your domain way better. As well, you will see way more code for you to analyze and understand. This way, you will get accustomed to the Ruby and the way you write the language itself. Yeah, so as I said, variety is the spice of life, so you should try to, immerse yourself into the tech stack and to try to see as much of different things as you can. And also here at Vinted, we have multitude of things that help you to transition. One of them being, as I mentioned, is your onboarding buddy. You can ask a lot of different things of them. Other thing is that we have accumulated quite a big resource catalog of previous people who joined, so you always can source that. And we also have this learning session concept where other engineers are coming and sharing their know-hows, their experience with various things, and of course one of them is being Ruby itself. So if you're interested after joining, everyone will be so happy to hear of your experience and your, some things that you find the passion in. So, and yeah, after language change, please don't forget that a lot of things are new, and I know that we are probably perfectionists by trade. But please remember that you need to take baby steps. You need to get to know something new each day. Because at the start, it can seem a bit overwhelming by a lot of changing things. But if you move bit by bit, it's going to be better. And I would advise to take this language change as an exciting new challenge for you to try. And I also compiled some resources. I actually crowdsourced this from my colleagues here. So if you want to take a picture, please do it now. I'm going to keep it for a couple of more seconds. Yeah, this is if you just want to try syntax, get some feedback to see if you like the language or not. And this is actually it. Thanks, everyone. And if you have any questions, please wait at the Q&A session or at the networking part. Just find me and ask. They can be personal or Java and Ruby related. So, thank you, everyone.
Thanks, Audronė. So now we'll hear more about transactional experience domain. I will also personally be interested to hear about that. And just a couple of words about Giedrius. He's our staff engineer in transactional experience domain. I personally have not worked much with him, but I've been in at least a few situations where if you challenge something and people just answer, Giedrius said so, no one challenges again. So there's quite a lot reliability in the talk. Good luck.
Yeah. Okay, thank you for the introduction. Yeah, so that's the thing with transactional experience. Nobody knows what we do. We don't know what we do. No, actually we do. So first things first, to know what we do, we split the member journey between making a purchase decision and the post-transaction. And we split it into 4 different stages. We call them the pillars of transactional experience. So there are a lot of things here. And there are a lot of things that are not written here. There are a lot of unhappy paths. So I've tried to basically take out the most happy path there could be. So we can take a look at the making a purchase decision phase. So we have teams that are basically working on price offers and creating the initial transaction. We have pre-order phase. So basically this is the checkout experience, shipping experience in the checkout. I mean, put-up point selection, label, estimation, and so on. So basically, we are creating the preliminary shipments there. We are updating the ledgers for transaction participants, and we are, well, most obviously processing the payment. And same goes for post-order. Whenever we process the payment, that's the point where we transition to post-order. So if the payment is successful, we then can use our preliminary shipment to get the actual shipping label, to start shipment orchestration, to communicate with Vinted Go or shipping services, and basically show the tracking information, perform auto actions, initiate reminders, orchestrate the feedback loop, complaints, and so on and so on. And basically, once this completes, this completes when we release the escrow amount to the seller. So this is an interesting concept because when the user buys an item, the money is not exactly immediately transferred to the seller. Rather, it gets transferred to an escrow wallet, that we call it like that. So the seller is not able to actually use that money until the buyer confirms that everything is OK. And once that is done, we say that we release the escrow amount, and we go into post-transaction phase. And in post-transaction phase, we issue invoices, we collect member feedback about the transaction, about the experience, about Vinted in general, and we perform payout orchestration through payment services as well. So if you look into this, you might see that we do just a bunch of orchestration. We have shipping domain, we actually have shipping business unit, that's called Vinted Go. We have payments domain that actually do the integrations with PSPs and different providers, and we are just in the middle of this. So we are doing the orchestration between a bunch of different services. So to simplify, as it was mentioned previously, we are working on DDD. So this is a very simple and very crude context map of our domain. So now everybody knows what we are doing. So in the middle, you can see we have transactions. So the transaction is the entity that gets created at the start. So basically, whenever the buyer first contacts seller, and it gets deleted. It actually isn't deleted, but it should be deleted at the very, very last stage. And then it connects with shipping integration, with payments integration. We have balances, user wallets, we have conversations, we have billing, invoices, billing addresses, taxes, and then also feedback block. So obviously in the real world, we have many, many more stuff here. We have a lot of unhappy paths, a lot of administration tooling that's also part of those contexts, but I just wanted to make it a bit simpler. So I would say that these represent the pillars of our experience. So yeah, all good things start from a vision. And our vision for at least transactional experience engineering is that we should provide a seamless and a hassle-free member experience while maintaining strong data, consistency guarantees, and ensuring resilient cross-service orchestration, and maintaining best-in-class performance. So consistency, resiliency, orchestration, and performance. So yeah, and I would say we follow the same general ideas like the rest of Vinted Engineering. We want to keep it as simple as possible, as minimal as possible. And these, I would say, are 4 main reliability technologies that we use. So from bottom to the top, we have database, we have distributed logs, we have transactional outbox pattern, Kafka events and commands, and then we have pending state pattern and reconciliation jobs. This is one of the oldest tricks in the book. And we can start from the smallest common denominator. That's our database architecture. So in an ideal world, like if you have, like, let's say 1,000 requests per second, you can just have a single database, and you can have everything done in a database transaction and call it a day. But for our case, that's not so simple, because we need to horizontally scale, we need to scale vertically, we need to ensure that our databases do not exceed some specific size limits. If I remember correctly, we have around 400 tables, so it's still rather impractical to start them in a single database. So everything starts from a database. So this is our smallest common denominator that basically sets the standard how we want to proceed with reliability. And we try to keep our database shards closely matching the context boundaries from the previously showed context map, meaning that we are going to have conversations database, payments database, shipping database, etc. We have some constraints in place that we say that if your operation, like an HTTP request, does something, it can read from multiple shards, but it must write to exactly one shard, meaning not only vertical but horizontal as well. And we have a bunch of in-house tooling that notifies about cross-shard operations. So yeah, one of the drawbacks of the current database architecture, I would say, is that it's likely that we might get partial commits. Like, our databases are not perfectly isolated. So, but we have in-house tooling that allows us to identify illegal operations. And we try to fix them in a timely manner based on criticality. There is a nice blog about this in Vinted Engineering website. You can read more from our SREs about it. And there is also one more thing. Like, it's no secret that we use MySQL. And the replication technology, I would say, is rather simple as well. So we always need to keep in mind that Vitess, and in turn MySQL, does not guarantee causal consistency. And what this means in simple terms, if you read from a replica some value, it doesn't mean that if you call the same method again, that the value will be there, because you might hit a different replica, and there is no way to guarantee that. So we always assume that there might be no data, and we need to be prepared for that. So moving up, we have locking solutions. So we use our own in-house, I would say, small framework for locks. We have a distributed ephemeral locking implementation. If you are familiar with Zookeeper, it kind of resembles that, but it's based on, well, again, MySQL. And basically, we try to ensure that all of our operations are idempotent, meaning that we can invoke them multiple times, and they will produce the same result every time, same side effects, actually. Yeah, and one of the drawbacks that we haven't met them yet, but hopefully we will never will, it's deadlocks. We try to minimize the locking scope. Like, if we have a huge operation, we need to ensure that the locking scope is very minimal. We try to fail fast in case something happens, in case we are unable to acquire the lock. And there's also the possibility, as I mentioned previously, of zombie locks. So because of our custom implementation, the lock is kept as long as the connection is open to the database, and that's gonna take some time. I'd say our average pod lifetime is 15 minutes. So in the absolute worst case scenario, we will keep the lock for 15 minutes. And then new rolling deployment will happen, and Kubernetes will restart the pod, thus dropping the connections. Moving on, this is a rather new topic, something that's new for us. It was introduced, I would say, like a year ago. That's asynchronous messaging. We try to reliably publish messages through Kafka. We try to refactor our monolith into less coupled packages and modules. And we chose to do it using Kafka. So now when we approach, let's say, a big chunk of code and we want to refactor it, we first start by identifying the constraints. So because previously all of the operations were implemented with the assumption that everything will be available immediately, meaning that if you process a payment, then the user balance will be updated, the invoice will be scheduled for generation, and a bunch of other stuff will happen immediately at this exact moment, so after the request finishes. And we try to revisit those assumptions, and we try to find maybe there are some places where the results could appear eventually. For example, balance update. So if we know for a fact that the payment was successful, we don't necessarily need to show it immediately. We can wait on maybe 1 or maybe 2 seconds. The user will not be able to tell the difference because the balance is displayed on a separate screen. And we can decouple a big chunk of code, thus reducing the transaction block, the database transaction block. And in order to do that, there is one small thing. We cannot reliably publish a message. It's not possible because Kafka doesn't implement XA transactions, or how they are called. So in essence, it's impossible to ensure that your database commit and Kafka message produce would happen at the same time or not at all. So it's not atomic, meaning that in some cases you might get Kafka messages that are published if you use the publisher directly from the code. In other cases, you might get database transaction that's committed, but the message that's unable to be published. So for that, we use a simple pattern that's called transactional outbox. And essentially, we still follow the least common denominator, that meaning database. So we always write all of our events first into the database, and then we have a background job that processes those events, reads them, and publishes them to Kafka. And yeah, so that's the last point, atomicity. So we always try to write a single shard, and that shard should always contain an outbox table where we would store all of the messages that need to be published. So obviously, this is still a new thing. We are still working on the tooling together with the platform team and SRE team. We are working on replicating Kafka, ensuring reliability. So it's still an early thing, but we might see that Ruby might not be the best approach here because of the way Kafka scales. Because Ruby threads are actually non-existent, they're fake, like Pythons. So we are investigating some options, how we can do it better. Maybe scale using pods in Kubernetes, maybe do some kind of orchestration magic, so to basically allow the consumers to consume more messages faster. And currently, we are just using Ruby threads. It works for our use case, but as I mentioned, we want to scale. Yeah, Kafka is very static, so configuration must account for all possible peak load times. So we always calculate the amount of requests we expect. We always calculate the peak requests. And basically, we are forced to always scale Kafka topics to that amount. And another thing that I barely touched in the previous slide was legacy UI. There are places where the Vinted application was designed to expect everything to happen at the same time, immediately. So it's hard to refactor because you need to take member experience into account as well. You cannot just, make all of those things into something that's asynchronous. And this is one of the oldest tricks in the book. That's one of the first, I would say, transactional experience reliability patterns. It's pending state pattern. So it's the good old way. In essence, this could be replaced by Kafka if Kafka supported delayed message queues, but because there is no general way to support delayed messages, this is something that we are still using. So for example, whenever we want to call a service, instead of calling the service, we register a pending state object, lightweight object in the database. So we do, again, going back to the first slide, database is our atomicity constraint. So we always register something in the database with pending state, then we do the external system call, then we update the state. And then in the background, we have a batch job that scans for those pending objects and reconciles them. So in case something bad happened, and we were unable to call the external service or something failed, we are aware of the fact that we wanted to call it. And the batch job, in case we were unable to, for example, receive response from external service, the batch job will be responsible for pinging that service directly and checking the status of the operation. So whenever we create the lightweight object, not only we set the pending state, but we also set the identifier that we are then providing to the external service, like payments or Vinted Go. So yeah, so this also has some drawbacks. We experience bursting reconciliation. So in case we have an infrastructure hiccup, we might see that our reconciliation jobs pick up a bunch of items which are in the pending state. And then we effectively almost do a distributed denial of service attack to our external service providers, because we pick up all of those and then we query all of them. So we are not doing any throughput control. And the reconciliation doesn't happen in real time. Essentially, it happens, I would say, in 20 minutes or 15 minutes. So it affects the user experience. The user sees in the message thread a spinner, basically, or loading state message or something like that. So yeah, these are all of our technologies that we use. And this is a very, again, simplified flow of how it looks like to process a payment request. So we start by registering a pending debit in the horizontal shard in Vitess. We call external payment service. We then acquire the lock, and we update the status in case the external payment service says that everything is OK. We add a message to the outbox, commit the database transaction, release the lock, and that's it. In case something fails, we have a reconciliation job that queries those pending debits from the database, again acquires the same lock, gets the current status of that specific payment from external service, and does reconciliation logic. Either fails or succeeds, or it all depends on a bunch of business rules. And then we also have outbox job that reads all of those outbox messages that we just added. It selects them from Vitess, it publishes them to Kafka, and it deletes them. And this also has a nice benefit because we are now expanding our data centers into different regions. This also adds a nice benefit that we can use Kafka producer batching. So we are no longer impacted by latency between data centers as much. And once this completes, we have a consumer for, in this case, this is just an example for fraud tracking, and it consumes a message that a payment was just processed. It does a bunch of logic behind the scenes that's not important for us, and then it makes a decision whether the payment should be refunded and reverted or whether it can proceed. So yeah, this is pretty much it. This is how it looks like, and that's the end of my presentation.
Thank you, Giedrius. You would think after these words and these diagrams there would be some questions, but there aren't. So just an encouragement. We work at Vinted channel. You can post your questions there. Otherwise, as I said, we'll pick them up live after the last presentation. So Oleg will tell us more about matching domain. Oleg is one of our old-timers. He's been around at Vinted for almost 9 years. So if you'll have some questions that us fairly newbies can't answer, then Oleg will.
Yeah, hello everyone. I'm Oleg. I'm a staff engineer at the matching domain. And let's start off with what matching domain does. So essentially, and this is where the name matching comes from, is that we match buyers to sellers. And on our platform, you can upload your clothing or other items you want to sell, and thus you create listings. So sellers create listings, and we need to find buyers for those listings, making both sellers and buyers successful. And in the whole flow, you can imagine like matching comes right before the transactional experience, before Giedrius's domain. So how do we do that exactly? So we, as a domain, own a bunch of product features that allow us to achieve exactly that, matching buyers and sellers. So here you can see a bunch of screenshots, and at the top you can see our search bar where you can type something in and find something to buy, for example. So this is search. Then next up we have the recommended listings block. So basically, you can find, like without prompting, without typing anything in, we might decide that you might like something, and therefore we can show it to you. Next up, we have favorites. And in this next screenshot, you can see this heart symbol, which takes you to your favorites. And then next up, we have our category tree, which is a part of our, we call like metadata system. And also matching owns parts of the infrastructure, which is meant to support all the other features, for example, like search. So before we go into the technical details, I want to show you the structure of the domain itself. So in our domain, we have 5 subdomains. It's search, ontologies, discovery, matching platform, and item retrieval and ranking. So in simple terms, you can think of subdomains as teams, but they're not exactly teams. But for simplicity, just assume they are. So I wanted to show you a bunch of product features we own and work on as examples of what you might expect if you, for example, as a backend engineer, you joined Vinted and matching in particular, and what you might be working on. So first up is search, and this is the high-level search architecture diagram I came up with. So at the left, you can see the web app. It's called Core. It's our biggest monolith. It's written in Ruby, and it uses Rails. So this is not up to scale in terms of the number of lines of code, of course. So like the Ruby monolith is the biggest one by far. And on the left, you can also see our primary data store, MySQL. And it's our primary like source of truth for almost anything that happens on the platform. So for search purposes, MySQL is not that great. So we use Elasticsearch, which is here on the right, to perform actual search. And in this case, we have to make sure the state in MySQL and Elasticsearch is kept in sync. And we achieve that by implementing this indexing pipeline, which is in the middle at the top. So the idea here is that whenever something happens to a listing, for example, it gets created, deleted, or updated, we publish a message in a Kafka topic, and the indexing pipeline listens to those events. This is done in Flink in particular. And we also use Redis as this temporary storage to come up with the final representation of each listing. So like every message could have a part of the listings data, and we need to come up with the final representation of an item, of like a listing. And then afterwards, we flush that data into Elasticsearch. On the querying side, we have the search service written in Rust. And its main purpose is to shield like web app from the complexity of querying Elastic. It basically provides a simple API for the web app to use. For example, the web app might send requests to the search service asking for listings from some particular category with having some particular size. So the search service would get a request with that data and convert that to Elasticsearch query. And as you might know, Elasticsearch query is this JSON DSL, so it's quite complicated. In this case, like search service takes care of all of that. So it then collects the response from Elastic and forwards that back to the web app. So one of the main challenges with search is the scale challenge, and to demonstrate the scale, like currently we have over 900 million listings, and imagine we change something about its representation, and something that change needed to be replicated in Elasticsearch. So imagine we have to do something with every listing on our platform. So if we take just 10 milliseconds per listing, it would take us 105 days to go through all the listings. So we need to be really smart of how we approach this, and Currently, it takes way less than this. So, but basically, like to demonstrate the scale we're operating in, like that's the way. So next up, we have re-ranking. And here's a structure diagram for re-ranking. So in the previous diagram, we had web app, search service, and Elastic. These are the same ones as before. And we also can see here re-ranker service. So the results from the search service are not shown as is on our platform. Before we show the results, we send those results into the re-ranker service, which has a purpose of rearranging the order of items of like those listings in order to show you the most relevant, the best content first. This service is written in Python because it's the obvious choice for machine learning projects. And at the core of this re-ranker service, there is a machine learning model. And as a backend engineer, you're not expected to know the details of the machine learning model, but you work on all the rest. So which means like wrapping the model into a service, maintaining the service, taking care of logs, taking care of scaling issues, creating like this client on the web app side and querying the re-ranker service and then so on. And the machine learning model itself is built by data scientists, which also work along with you in your subdomain if you work on re-ranking. Next up, we have homepage. And homepage is the first page you see if you open our website. And also, it also exists on our app. And if you're logged in, that's the first page you see. So in this case, like MySQL web app and the search service is the same one as before. Recommender service is very similar to the re-ranker service, but it's a different instance of very similar code base. But its purpose is not to rearrange items, but it's more to suggest you specific like things to buy, for example. So on the homepage, we have a couple of different blocks, and each one has some data source it queries, and it shows, for example, that one of the top is for you is probably the recommended items. So it might query then the recommender service and show you the results from there. And also some of the blocks just use like the search. For example, if you've bought a particular brand, we might show you more items from that brand. And also at the very bottom of it, we have feed, which uses Redis as the primary store, and it just shows you items that have been like recently uploaded. Next up, we have the metadata system, and the metadata system is basically the system of assigning data to every listing. For example, on the left, you can see this is the screenshot of our website where it shows you the category tree, and every listing is assigned a category. So we need to have a system of like what the categories are, what should be in every category, what the category tree looks like, and then so on. And on the right, you can see a part of our item page, and you can see brand size, condition, and color there. And this is also a part of our metadata system, which allows us to basically classify in different ways what content we have on the platform. So we have a subdomain which works on the metadata system, and as backenders, you work on like the technical implementation of providing the data, saving the data, and so on. So next up, we have Vespa, and one subdomain which was created fairly recently is matching platform, and their main purpose right now is to investigate Vespa as an alternative to Elasticsearch. And this is done so that perhaps we can combine the re-ranker service and Elastic all in one, because Vespa can run similar machine learning models as we run in re-ranker service, but inside of the data service, the data store perhaps. So we could simplify this architecture diagram to having just Vespa, for example. So we have the whole subdomain dedicated to trying it out and seeing if it works for us, and seeing if it brings any benefits to actually having Vespa instead of Elasticsearch. So that's it. Thank you.
Thank you. You can't go anywhere because we got some questions.
Oh, yeah.
So that's good. Well, my heart will go to Tyrell because he posted 3 questions, so that's nice. We'll just give a second to Giedrius and Audronė to come up. Whilst they are coming up, Oleg, I think one question to you is, since it came up in your presentation, how does individual services communicate with each other? Is it gRPC or something else?
So the main one is just straight up HTTP calls for most of them, but we have some cases where we use Kafka to communicate, but I guess the most common one is still just HTTP, like JSON. Yeah.
Thanks. Giedrius, maybe a question to you because it came up whilst you were talking, I think. Is customer data encrypted?
Hello. Okay. So, yeah, we always try to follow the best practices for customer data security, and we take it very seriously. So we actually never even process the data that could be treated as sensitive. So we always communicate directly with our payment providers. And, well, the architecture for that could be another presentation because it's very complicated. In essence, we only store data that's needed for us. We allow the users to anonymize themselves. Even if I said previously the transactions are not deleted, the fields in the transaction are anonymized.
I think it might be the reason why the question popped up.
Sorry?
Since you said that they are not anonymized, maybe that's why the question popped up.
Yeah. So we are actually anonymizing everything as much as possible, and we follow the best practices for credit card handling and payment processing, and yeah.
Okay.
Yep.
Thank you. Audronė, question to you. How do you test your services?
We have our spec. It's a testing framework for Ruby on Rails. Also, we have a lot of integration tests that are written not by backenders, but by our QA test automation engineers. What else? I don't know. I think that's it, like for the quick overview.
Mm-hmm. Oleg, another question to you. What is the reasoning behind using Rust in search?
It was created at the time we didn't have a common language for high performance services. So we knew that Ruby was not an option there. So we just picked Rust, I guess. So it wasn't like, I don't know. But basically, we've later standardized, I guess, on Go. But it was written before that. And just as an option, it was chosen to use.
Thanks. Another question to Giedrius. What technologies does the tech side use to provide data for business for further analysis?
Yeah, so actually we have data lakes, we have data warehouses, and we do, I believe every night we do batch imports. So we import our production databases into our data warehouses, and then we have Looker integration, we have Hadoop, I believe. We have Spark-based analytics jobs. We have Looker and a bunch of other analytics-related tooling built on top of data warehouse. So all of our decisions are actually influenced very much by data that's coming from there.
Thank you. Audronė, what internal alerting monitoring tools you use, something like Sentry?
Good question. Like from the top of my head, I cannot answer that. Maybe you guys can. We rely heavily on Grafana, and we keep our logs in Kibana, so we monitor that. We also have that Datadog integration, where we monitor our successful and non-successful responses, and most of the alerts are based on those tools.
Thanks. I suppose then, Giedrius, question to you. What happens with funds in the time from collecting from buyer until issuing to a seller?
Until issuing to the seller. So they're actually, they are stored in seller's wallet, but that's, well, there are a lot of legal reasons behind this. But there is a special wallet that's under seller's name, but the seller cannot actually use that money until the buyer confirms that everything's okay. So it's still seller's in a way. It's actually part of our PSP integration, so maybe that question would be better for payments domain. But as far as I'm concerned, it's still in seller's wallet, but there's a special escrow wallet just for those cases. And then once the buyer confirms, we transfer from that wallet to another seller's wallet, the main wallet, and then the seller is allowed to make payouts from that wallet.
Thanks. Oleg, why Vitess? What was explored and why alternatives dropped?
In my talk, I haven't even mentioned Vitess, but I tried to keep it simple and had just this MySQL, right? So I guess Vitess was chosen as this obvious choice for MySQL because it really works well with it and was created exactly for the use case of having this, for example, horizontal shards. And we at some point we needed to have to scale even more than vertical shards allowed us, and we've chose Vitess, I guess.
Thank you. Audronė, do you think Go language was a good choice?
That's a spicy question, by the way. As I said, I am a strong believer that language is just a tool. And all of the languages have the beauty in them and proper use case. I am personally happy with the choice of proceeding with Go, because for me it seems like a way smaller learning curve for people compared to Rust, of course. And yeah, so I think that this language will be a very good addition to our tech stack, because it focuses on performance.
Thanks. Did you explore something like Firecracker?
Can you repeat the question, please?
You mentioned short-lived pods. Did you explore something like
Oh, I think
Firecracker?
people are confused because we had this, I guess it's Giedrius' question.
Okay.
Yeah.
Sorry,
Short-lived pods.
Pay attention.
Oh.
You mentioned
Yeah. I know.
You mentioned short-lived pods. Did you explore something like Firecracker?
Actually, that might be a better question for SRE guys, and they're not here, so I can only guess. Maybe they have something in the pipeline, but I don't know actually. So, but yeah, in essence, I believe we do a deployment every 15 minutes in general, so like a couple thousand pods in 15 minutes, maybe more. And yeah, that's the gist of it. So I don't think that we have anything else.
All right. Thanks, Oleg. If there were unexpected cases of the majority of systems going offline, or what were the reasons, events, can you remember? Did we go offline for a long time?
I don't remember any any incidents that major. Oh, we had an incident how many years ago? I don't remember, but some internet cable got cut, and the connection to our data centers in Vilnius, wasn't available. So the whole Vinted was down for a long time. I don't know how many, a couple of years, maybe a day or two. But I don't know, it wasn't like a technical issue on our side. So yeah, perhaps this, but I don't know. We haven't had any. Oh, I don't want to jinx it, of course, but I don't think we've had any very, very major multi-day outages or anything.
Thank you. Audronė, can you elaborate on how developers work? Is it remote, not remote? What is the setup?
Okay, so we are a hybrid company. Currently, we don't have any enforced, distribution between the days in the office and days at home. Yeah, we allow all of our employees to work remotely. Of course, you need to be registered in the country you're working from. Yeah, and I think that is the approach that we will be proceeding, because we see that a lot of people really love remote work. I myself sometimes really like to go to work from my parents for a week or two. So yeah, officially we are hybrid, but you can choose the place where you want to work from. Of course, company policy encourages you to come at least 2 days in a week, but it's not enforced. So we are just hybrid.
Giedrius, how do you document or enforce contracts between services?
Good question. No, I'm just joking. So we actually adopted RFCs and ADRs recently. So whenever we do some change that crosses team boundaries, service boundaries, or any other boundaries, we create an RFC. We have staff engineers responsible for that. So RFC, in short, is for request for comments. So basically a small design document. And based on that RFC, we start discussions. And during those discussions, we define the API contracts. And for us, it's a bit different because in general, if you're working in a project company, you usually need to define those API contracts because you most likely have clients that will need to consume that API. For us, it's a lot more easier, I would say, because we are creating services between ourselves. So we don't need the strict enforcement, but obviously we do align before using RFCs and so on.
Oleg, are there any engineers who work primarily using Go?
At our domain, not exactly. It's been introduced fairly recently as well. I think like the major use case for Go is actually in the SRE domain, or not? Is it domain? But basically, SRE is used a lot because it's a very infrastructure language. Let's put it this way. But yeah, it's gaining adoption as well. But there's no teams at our domain which work on Go specifically.
I can see there is one question regarding Kafka, CDC, and Flink, and we're actually lucky enough to have Rokas. Rokas, could you wave? I will not ask you to come and answer the question now, but I just wanted to suggest if you have questions like this, I think Rokas is staying for drinks, so you can come up to him and ask. Thanks, Rokas. I don't know whom that's. I guess. Audronė, how frequently you shop on Vinted?
Oh, okay. I do shop a lot on Vinted. Actually, my whole outfit, besides the blouse, is from Vinted, by the way. I really do love it. I am personally not a fan going to the shops anymore after COVID and everything, because I get so overwhelmed by stuff. And I really like our search capabilities. So whenever I have an idea what I want to buy, I just go firstly to Vinted to check if I see something that I like. And then after that, I go to, other sites that sell new things.
Oleg, do you still use Rust at Vinted? Personally?
Yes. This changes the question, right?
No, I added personally. There's no personally.
Okay, so of course we still have the search service and we still maintain it. We still develop it actively, so yes. However, probably if you're an engineer looking for Rust work, probably, so I wouldn't expect Rust specifically. You'd have to if you join Vinted, you'd have to be pretty lucky to be in that specific team working on that specific project on search, for example. But yeah, we still use Rust, yes.
So I can see Tyrell is wondering about your shopping behavior and what you're selling. So working in trust and safety, I'll be a little bit suspicious of some questions then. But maybe just a sentence to add regarding shopping at Vinted. Vinted itself also encourages shopping at Vinted, meaning there is a personal budget individual gets and we all get to use it, as well as, of course, we are all encouraged to use it not only to buy, but also to sell. So if we're not the users, we can not very well work on the services we provide, right? Giedrius, how many repos do you have and how do you share components?
We have a bunch of repos, I think 300 or something like that, maybe even more.
No idea.
And we have all kinds of repositories, so like, we have core monolith, where our main meat of the application lives, but then we have a bunch of service repositories, we have a bunch of libraries, platform-level libraries, or custom frameworks, which is interesting coming from Java, because in Java you always just use Spring or whatever, and it provides you with a bunch of integrations. In Ruby you have to most likely do it yourself. So we don't do mono repos, we have separate repositories, and the landscape is very, I would say, wild. But I guess that's our policy. We encourage writing code in separate repositories instead of trying to cram everything into one. And how do we manage dependencies? Yeah, that was the question. I guess the same way like everybody else does it. So we do internal tooling for, like, Ruby doesn't help in this case, sadly. So we have internal builds, we have internal versions, and then we update those versions in our monolith. So whenever we release a new library, a new patch, whatever, we release it, and we update the version. What's good, though, is that we don't need to compile stuff, because Ruby is interpreted language, so the release process is a lot easier. It's basically just zipping the repository and uploading it into Nexus or whatever. So, yeah.
Okay. I don't know, like maybe you can, do you do any open source work?
Like,
I would assume it's, are we all permanent employees or do we?
Yeah. Sometimes, yes. It's mostly whenever you need something done which requires you to, for example, in obvious cases where you want something fixed or introduce some new feature into a library that's open source, then you work on open source. It's not a completely standard practice to open source internal tools, but internal tools and like libraries, but we've done multiple ones before, of course. But yeah, it's mostly, as an employee, you mostly work on closed source, like the internal projects, repositories. Some of them, like if it makes sense, are open source, but most are not. So yeah.
Actually, we have no more questions on Q&A, but we can take some live if you have some that you didn't post. It's that moment like at school, you know, when teacher asks a question and everybody puts their eyes down so they're not asked. Any questions? All right, but then I'll just encourage and remind of the opportunity that will be going on the roof terrace. Some people will help us get guided. So we'll be there. Rokas will be there. And you can ask us personally the questions maybe you didn't ask yet. We are here to answer them. Also, we have some talent acquisition people. Maybe you could wave or stand up a little bit so you know whom to approach in case you'd like to do that. So let's go for drinks, right? Thank you.